Let us consider a simply supported beam AB having a span of 36 meters, and let C be the midpoint of this AB. There is a train load from W1 to W5 with intensity of 160, 200, 200, 100 and 100 at a given distance between each other. We will try to estimate the value of maximum bending moment when this load moves over this beam. For that, first we need to estimate the value of the resultant as well as its location from some reference. The total resultant of this force will be just the sum of these forces, which is 760 kilonewtons, and it will act at some distance from some reference. We will keep W5 as our reference. We will take moment about W5. So the moment due to all these loads about W5 must be same as the moment due to the resultant about this W5. So from that we can calculate R, which is nothing but the distance of this resultant from W5. And for the maximum bending moment, we have to remember these things. Our load which is nearer to the resultant, below that load, our maximum bending moment will occur. And its position, this load must be placed on this beam such that when the distance between this resultant and W3 is divided equally by this midspan, then for that particular position of this load on this beam, we will have maximum bending moment below W3. So we have kept this moving load such that W3 and R, they are placed equally about C. The distance between W3 and R is split into two halves by C. We know the distance of R from W5, it is 8.55. So the distance between R and W3 can be calculated as 8.55 minus 3 minus 4.5, which is 1.05. So the distance between RA and R, it will be 18 plus 0.525, so it is 18.525 meters. Now we need to calculate the value of the reactions RA and RB. We will take moment about RA. Since this is an external hinge, the moment about RA must be equal to 0. There are only two forces, like RB is acting, it will induce a counterclockwise moment, and this RA is this reaction R is going to produce a clockwise moment, and RA is acting at a distance of 0 about A, so we can ignore RA. From this expression we can calculate RB, and RA can be calculated as 760 minus 391.14, it will be 368.86. And the we are supposed to find the maximum moment just below this W3. Maximum moment below W3. This will be, we can consider either to the right of this W3 or to the left of this W3. We will consider to the left of this W3. RA is acting at a distance of this 18 minus 1.05 divided by 2. So this is the distance at which this RA is acting from W3. And one more load is at a distance of this W5 is acting at a distance of 7.5, W4 is acting at a distance of 4.5. We have to consider all those loads and the moments induced because of these loads, and this value comes around 5245.83 kilonewton meters. This is the maximum moment when this train load moves over this span, and this maximum bending moment occurs below W3.